Hello, today we will be discussing quadratic equations and how to solve them. This corresponds to the free OpenStax textbook for college algebra. It corresponds to section 2.5. So we're going to be talking about how to solve these quadratic equations in several different ways. So the first method is to solve by factoring. So if you have two things multiplied together, let's say we have A times B and it's equal to 0. Well, the only way you can get 0 when you multiply two things together is if one of them is 0, or they could both be 0. So that means that either A equals 0 or B equals 0. This is called the zero factor property. So if we can figure out how to write these quadratic equations as factors, then we can say, well, one or more of the factors must be 0, and we can solve simpler equations that way. So let's look at that. All right. So for number 1, we want to solve by factoring. We want to make sure everything is on the left-hand side and it's set equal to 0. That's how you set these up for factoring. That is the case with number 1. So now we're ready to factor. We can see that we have 3 terms. So this is a trinomial. So this is a term, this is a term, and this is a term. Remember, terms are separated by plus or minus signs. So there are 3 terms. And since there is understood to be a 1 in front of the x squared, we factor this by simply writing down 2 sets of parentheses. We split up the x squared into x and x. And then we have to figure out what multiplies to get negative 21. So what multiplies to get that, and what adds to get 4. So what 2 numbers will work? So 7 and 3 give us 21. And if we have a positive 7 and a negative 3, positive 7 times negative 3 is negative 21. A positive 7 minus 3 is a positive 4, so that will work. So now this is a product. X plus 7 is one factor, and x minus 3 is another factor. There's understood to be a multiplication sign here, right? So it's one factor times another. So since we have a product, that means that one of these factors must be equal to 0, or they could both be equal to 0. So we can set each factor equal to 0 separately. And now we can see these are very easy to solve, right? For the first one, we simply need to subtract 7 from both sides to get the x by itself. So we get x equals negative 7. And for the second one, we need to add 3 to both sides to get the x by itself. And that'll give us x equals 3. So there are 2 solutions to this equation. Your 2 solutions are negative 7 and 3. You give your solutions in curly brackets. That denotes a set. So the curly bracket says, here is my set of answers. This is my set. Every answer that you have, you put in there separated by a comma. Now, here's something to keep in mind. The degree of the polynomial, the degree of the polynomial is the highest exponent on any variable. That's going to tell you the number of solutions you should expect. Now, you could have the same solution twice, so you could get a 3 and a 3, and then it looks like you only have 1 solution, but you really have 2 solutions. So your exponent is telling you how many solutions you should expect to get. You will always get that many or fewer numbers as your solution. All right, let's look at number 2. So number 2, we're asked to solve by factoring. So we're going to factor this. The first thing you should do is look to see if there's a greatest common factor that you can factor out. And in this case, there is. Everything has a 4 in common. So I'm going to pull out a 4. That will give me x squared minus 3x plus 2 left over when I divide out a 4. And now I'm going to bring the 4 down, and since what's in the parentheses is a trinomial and it has a 1 in front of the x squared now, I can break that up. So my x squared breaks up into x and x. What multiplies to get 2 and adds to get negative 3? Negative 2 times negative 1 is a positive 2. And negative 2 plus a negative 1 is a negative 3. So that will work. And now we're going to set each factor equal to 0. So the first factor is 4. So 4 equals 0. There's no variable there, so that does not lead to a solution. The next factor is x minus 2, so I set that equal to 0. And then the third factor is x minus 1, so I set that equal to 0. So I'm going to end up with two answers. So the first answer is going to be a positive 2, so x equals 2. And the second answer is going to be a 1. Okay, I had an exponent of 2, so I should expect 2 or fewer answers. So my two solutions are 1 and 2. And it does not matter what order you put these in. You could put it in like that, or you could put the 2 first. So when you're doing a set like this, the order doesn't matter, just as long as you include each different answer. All right, so let's look at number 3. Number 3, we still want to solve by factoring, but it's not set up for us yet. So remember, when you solve by factoring, you want everything on the left and have it set equal to 0. So we're going to start by subtracting 5x from both sides. Okay. Now notice it cancels out on the right. On the left, those are not like terms, so you're going to have 4x squared minus 5x equals 0. So now you've got it set equal to 0. Notice that you only have two terms. So what you want to do at this point is factor out the greatest common factor. So we have 4 and 5, there's no number in common, but they do both have an x. So we're going to factor out an x, and that will leave us 4x minus 5. And so now we have two factors. X is a factor, and 4x minus 5 is a factor. So x equals 0, that's one solution, and it is a solution because it has a variable. And then 4x minus 5 equals 0 will give us the other solution. So we're going to add 5 to both sides, and that'll give us 4x equals 5. And then we're going to divide by 4, so x equals 5/4. So those are my two solutions. So 0 and 5/4. Okay, so next we're going to look at how to solve quadratic equations by using the square root property. So this is going to be easier to use if you only have something squared set equal to a constant. So if you look at number 4, we don't have an x term. We just have x squared, and we have a constant, or a number. So if you have that, what you want to do is get the x squared by itself on one side, and then you're going to take the square root of both sides of the equation. So this, we will take the square root. When you introduce a square root into an equation where it wasn't before, you have to put plus or minus. So that's going to give us x equals plus or minus. The square root of 36 is 6. So that's two different answers. You can put that in with a plus or minus, that's fine. Or realize that what this is a positive 6 and a negative 6. Those two sets mean the same thing. So if there's not a plus or minus symbol in your homework, you need to use your two numbers, negative 6, comma 6. Okay? But realize that's two answers, right? Okay, let's look at number 5. Number 5, I have the x squared by itself on the left, and then a number on the right. So this is where I can use the square root property, and you have to take the square root of both sides. So the negative goes under the radical. Don't forget to write the plus or minus. So now we have x equals plus or minus the square root of a negative, remember that's an I, and the square root of 225 is 15. So that'll be plus or minus 15i. So again, you can use a plus or minus and put it in curly brackets, or you can write negative 15i and 15i. So either of those would be acceptable. All right, number 6. Now this one looks a little bit different, but it actually is still one that you can use the square root property on. If you notice that this whole thing is squared, the whole thing is squared and it's set equal to a number. So you can go ahead and take the square root of both sides, put a plus or minus. So what happens here is the square root and the square are opposites. They undo each other. So you'll have x minus 3 left on the left-hand side, and plus or minus the square root of 7. Now 7 is not a perfect square, and you cannot reduce it because it's prime. So that's all you can do with the right-hand side. And now what you want to do is get the x by itself. So to do that, we're going to add 3 to both sides. So it cancels out on the left. So you get x equals. Now the 3 is out of a radical, right? There's no radical. The 7 is under the radical. So you cannot combine the numbers because they're different, right? So you're going to have 3 plus or minus the square root of 7. And that is all you can do because you don't have like terms. So your solutions are 3 plus or minus the square root of 7. And again, remember that that's 2 answers. So you could also put in 3 plus the square root of 7, comma, 3 minus the square root of 7. Those are your 2 answers, okay? All right, let's look at number 7. So number 7 is similar to number 6, except you've got that plus 8 on the left-hand side. So the first thing you need to do is get the thing squared by itself. So you need to subtract 8 from both sides. Because now I have x plus 5 squared by itself on the left, and I have a negative 6 on the right. At this point, you can go ahead and take the square root of both sides since the left-hand side is completely squared. Don't forget to add the plus or minus on the right. All right, so now the square and the square root undo each other, so I have x plus 5 on the left. On the right, okay, now I've got plus or minus. The negative comes out as an I, and I'll leave the 6 under the radical. The 6 will not break down, so it breaks down into 2 and 3. There are no pairs, so that's as simplified as that radical gets. Now I need to get the x by itself. So subtract 5 from both sides. And so we get x equals negative 5 plus or minus I squared root of 6. Now you can go ahead and write this in this way. So those are my 2 solutions. And you might be wondering why the I isn't last. So the I is attached to the square root of 6. So you can write it like this. But here is the reason. If you have a square root, you often write it in front of the square root symbol. Is because you have to make sure the I is not under the radical. So if you're sloppy and you write your radical sign like that, okay, you're not sure if the I is under or not. So in order to make it very clear, instead of writing it like that, you write it with the I in front of the radical so that you know it's not under the radical symbol. But notice the I piece still comes last. So you would not want to write it plus or minus I squared root of 6 minus 5. That would not be acceptable because then the imaginary piece is first. Okay. So again, this is why we write it like this. All right, so now the third method for solving quadratic equations is completing the square. So factoring is great, but it doesn't work every time. It only works if your polynomial is factorable. And completing the square, not completing the square, square root property is also not too challenging, but it only works if you have one side squared. So for number 8 and 9, we're going to try completing the square, and this method works every single time. Now, this method does get much trickier if there's a number in front of the x squared other than a 1. So for our purposes, so we can see the method, we're only going to do the case where a is 1. But know that if it's not a 1, it's much more complicated, and I won't ask that you do that, okay? So let's look at number 8. Completing the square, your goal is to rewrite the trinomial on the left so that it's a perfect square trinomial, and that you can rewrite it so that you can use a square root property. So that's what we're trying to build to. But this is how we're going to do that. So what you want to do is you always want to keep everything with a variable on the left, and you're going to move the constant to the right. So since it was a positive 6 originally, in order to get it to the other side, you subtract 6 from both sides. So you have 8x squared minus 8x equals negative 6. I left a blank here because I'm going to add a plus blank, and it's always a plus. So I'm going to add something to the left-hand side in order to make this a perfect square trinomial, but whatever I add to the left, I have to add to the right of the equation to keep it balanced. You're always going to add the same thing. You're going to find it the same way. You're going to take this middle coefficient, okay, the middle number, and you're going to divide it by 2 and square it. So negative 8 divided by 2 is negative 4, and then square that, you get 16. So 16 is what goes in this blank. In order to keep the equation balanced, I'm going to put a 16 on the right-hand side as well. All right, the reason we did that is because now the left-hand side will factor. I'm going to write down my parentheses. I have x and x. What multiplies to get 16 and adds to get 8? Well, that will be 4 and 4, negative, negative. Notice that these are the same term, or the same factor. That will always happen when you're completing the square. If you don't get the same factor repeated, then you did not complete the square properly, or you didn't factor properly. Okay. So what you're going to do is, instead of writing it like that, you're going to write it as x minus 4 squared, because we had 2 of those, equals negative 6 plus 16 is a 10. Now, since the whole left side is squared, you can do the square root property. So the rest of this problem is just using the square root property, which we've already learned how to do. The only new part for completing the square are the first 2 steps. Now you're just going to use the square root property. Okay, so we're going to have x minus 4 on the left equals, I don't really need the parentheses, so x minus 4 is equal to plus or minus the square root of 10. The square root of 10 will not simplify. Now I just need to add 4 to both sides. So I have x equals 4 plus or minus the square root of 10. And those are my 2 solutions. Okay. All right, let's try one more. So let's try number 9. So for number 9, remember the first step is to get everything with a variable on the left. So x squared plus 4x, and then you put a plus blank, equals, we're going to move that negative 3, so we're going to add it to both sides. So now it'll be a positive 3 plus blank. To figure out how to fill in the blank, remember that you take the coefficient of x, divide by 2, and square it. So 4 divided by 2 is 2, squared is 4, so 4 will go in the blanks. And now we're going to factor. So the left-hand side is going to be x and x, 2 and 2 plus plus, and that is the same thing, right? We're expecting to get the same thing twice. So now I'm going to write it as x plus 2 squared equals 7. Now I can use the square root property. So square root both sides. Don't forget to put the plus or minus. The square and the square root undo each other. So I have x plus 2 equals the plus or minus the square root of 7. Last step, get the x by itself. So subtract 2 from both sides. So x equals -2 plus or minus the square root of 7. So those are my two solutions to this quadratic equation. All right. So again, that's completing the square, and it works every time, but it does get much more complicated if the coefficient of x squared is anything other than 1. Okay, so here is the quadratic formula. This is another method that works every single time. The formula is given in the gray box. You can see it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So look at the equation that's given up here, right? You have a is the number that's in front of the x squared. B is the number that's in front of the x, and C is the number that's by itself. It's the constant. And so that is how you're going to know what to plug in to each of these pieces in your formula. So this A, B, and C is coming directly from your original equation. So it's key that your original equation, before you try to use your formula, is set equal to 0, and it's in the order x squared, x, and then the constant. That way you don't get confused with what your A, B, and C are. Then you just plug it in the formula and you simplify and you get your answers. You will have to have this formula memorized. So this will not be given to you on your test. You need to memorize this. And if you like to memorize things with mnemonics, you can Google the song. There's a song, It Goes to Pop Goes the Weasel. That might help you memorize it. But just find some way to memorize this formula. All right, so if we try it, number 10, we notice that we have it in descending order. So we have the x squared piece first, then the x, then the constant. It is set equal to 0. So I can label these A, B, and C. So those are my A, B, and C's that I'm going to plug into the formula. So x equals the opposite of B. So I have a -8. So that's going to be a +8. So the opposite of B is -8, so that's going to be a +8. B squared, so -8 squared, minus 4 times A, which is 2, times C, which is -5, all over 2 times A, which is 2. So the first part is making sure you plug everything in right. Next, what you want to do is simplify. So this is going to give me 8 plus or minus the square root. -8 squared is 64. Note that this term will always be positive because you're squaring whatever you have. So it doesn't matter if it was a negative or positive to start. Your answer here will always be positive, okay? Now you want to evaluate your signs. So this is what I encourage you to do. Look at this sign, all the signs here, count how many you have. So since I have two negatives multiplied together is a positive. So this will be a plus. Once you get your sign established, then just multiply the numbers together. So 4 times 2 times 5, that will be 40. So it's plus 40 over 2 times 2 is 4. All right, now we're going to add what's underneath the radical, so that's 104. Now we want to try to reduce that 104 if we can. So I'm going to go up here and use the space up here. 104 divided by 2, that's going to be 52. 2, 26, 2, 13. All right, so now I've gotten my prime factor tree done. I'm looking for pairs, so this pair of 2's will come out, and then this 2 is left over, and that 13 is left over. Because what I'm trying to do is I'm trying to simplify the radical of 104, right? Remember, you have to do that. So now we have 8 plus or minus. The pair of 2's comes out as a 2. The 2 and the 13 that are left over multiply back together, so that'll be 26 over, let's see, 4. All right, now the last step here is trying to see if everything outside of the radical has something in common and can reduce. So you're kind of looking for a triangle. Does every term have a common factor? Well, yes, it does. I can divide all of those by 2. So 8 divided by 2 is 4, 2 divided by 2 is 1, and 4 divided by 2 is 2. Since I can divide them all by a common factor, I can reduce. So it'll be 4 plus or minus. The 1 is understood. It doesn't need to be there. Over 2. That is as far as I can take it. So you cannot reduce the 4 and the 2 because there is no number here to reduce with. In order to reduce, like above, every term has to have a common factor. So there's nothing here in front of the square root of 26 to reduce. So you cannot reduce the 4 and the 2. So do not make that mistake and reduce the 4 and the 2. This is it. This is your answer. So I can put curly brackets around it, and that's my 2 solutions. All right, let's look at number 11. It's in descending order. It's set equal to 0, so I'm ready to start using my formula. So x equals the opposite of b. So b is a positive 4, so it'll be a negative 4. Plus or minus the square root of b squared minus 4ac all over 2a. So now we're going to reduce, so negative 4 plus or minus the square root of 16. I only have one negative, so it's going to be minus 8 all over 2. Okay. Now I can finish what's under the radical, so it's going to be negative 4 plus or minus the square root of 8 over 2. Now I want to reduce the 8. So the 8 is 4 times 2, which is 2 times 2. So I have a pair of 2's that'll come out and 1 2 left over that'll stay under. So this is going to be negative 4 plus or minus 2 square root 2 over 2. Now again, notice here I have all of these numbers outside of the radical can be divisible or are divisible by 2. So if I divide by 2, I'm going to get negative 2, 1, 1. And so I can reduce that to negative 2 plus or minus the square root of 2. And then since it's over 1, that's understood to be a 1. I don't need to write it. So those are my 2 solutions. So we have looked at 4 different ways to solve quadratic formula, 4 different ways to solve quadratic equations. Remember that the completing the square and the quadratic formula work every time, but you should know how to use all the different methods. Okay, so the last thing we want to talk about in this section is the discriminant. The discriminant is the part of the quadratic formula that's under the radical. So it's the b squared minus 4ac. So if you look back at the quadratic formula, that's the part that's under the square root. This is going to let you know how many solutions, 1, or two solutions that you have, and what type they are. So we're going to determine the discriminant, state how many solutions there are, and the nature of the solutions. We're not actually going to solve it all the way out. So we're going to use the b squared minus 4ac. So b is negative 6 minus 4 times a is 2, c is 7. So this will be 36 minus 8 times 7 is 56. So then if we have 36 minus 56, we will get negative 20. Now what we want to do is we want to look at our chart up here. So if the discriminant is equal to 0, we have one rational solution. If the discriminant is greater than 0, so in other words, if it's positive, okay, and it's a perfect square, we have two rational solutions. If it's greater than 0, but so positive, again, if it's positive but it's not a perfect square, you have two irrational solutions. And then we have, if it's less than 0, which means if it's negative, you have two complex solutions. So our example was negative 20, which means we'll have two complex solutions because it was negative. All right, number 13, b squared minus 4ac. So b is 5, so 5 squared, a is 3, c is negative 8. So 25, these two negatives, that's going to make a plus. And then we have, let's see, 12 times 8, 16, 96. So plus 96. 25 plus 96, 9, 10, 11, 12, 121. Okay, so our discriminant is 121. 121 is positive, so it has to be one of the middle two cases. And 121 is a perfect square because the square root of 121 is 11. So that's going to be the second case. It's positive and it's a perfect square. So there are two rational solutions. All right, number 14. We have b squared minus 4ac. So we have negative 4 squared minus 4 times a, which is 2, times c, which is 2. So that'll be 16 minus 16, which is 0. Okay, 0 is the very first case. So we will have one rational solution. That brings us to the end of the section. Thank you for watching.